Namaste children and welcome back. Namaste children and welcome back for our next session from the topic basic geometrical ideas. Okay, already we have seen few more sums in the basic geometrical ideas. Now today what we are going to see is based on the lines. Okay, so let's move further with the sums left out from exercise 4.1 from the basic geometrical ideas. Let's begin with question number 8. So what is asked in question number 8? They are telling that mark 4 points E, F, G, H. What they are telling here to mark us? 4 points E, F, G, H such that no three of them are collinear. No collinear means they should not lie on same line. That is no collinear. Okay. Now same way we are going to do it. That is, I am going to mark 4 points, out of which 3 are non-collinear. So I will give here a point, that is E, here F, here G and here H. Okay. So I am going to write here as E, here as H, and here the point as F, and here the point as G. Now further what they are telling again, such that no three of them are collinear. Draw lines through the points taking 2 at a time and answer the following questions. So by taking 2 at a time, I need to draw the lines passing through it. So first line I will draw A, which will pass through these 2 points. Okay. So here I am going to name it as line A. Now same way, one more line I will draw from H to E, from H to E, okay, which will pass, and I am going to name it as B, okay. Now same way here, I will draw one more point which will pass from G and H, for what I am going to name as E. Now same way, the line will pass from this between both of them and will join the point F, which will get here a line as F. Okay. Now same way I will draw one more line passing from the E and F, which I am going to name as C. Now same way here children, you can see that one more line I can draw which will pass from these 2 points at a time, that is D line. So I am going to write here as a D line. So here I have got A, B, C, D, E, F. Okay. So now here they are asking based on this question, that is, how many lines can you draw? So I can write here, I can draw 6 lines, that is 1, 2, 3, 4, 5, 6. So here I will write that 6 lines we can draw, which are named as A, B, C, D, E and F. Okay children. Now same way, what is the second question? Name the lines concurrent at each of these points, which are concurrent. Concurrent means intersecting, isn't it? At one point. So those are here line EF, then line EH, again line FG, again line GH and line EH. These are all the concurrent lines. Can you see here? That is line E, H, line F, G. These are all the concurrent lines. Okay. Now same way here they have asked you the next question, that is, how many lines can you draw if you take the points 3 at a time? If I 3 at a time, that is 1, 2, 3, then how many lines? I cannot draw any line. So my answer over here is none, because what reason they have asked that we are going to mention is because no 3 of them are collinear. No 3 of them are collinear. So is this concept regarding the collinear points and lines Okay, let's move with the next question now. So now let's begin with the question number 9. In question number 9, they are asking us to answer the following questions. What are the questions asked over here? So here come with the first question, that is, what has a position but no magnitude? Now magnitude means measurement. Okay, now let me explain you which thing is that which can be marked but cannot be measured. Yes, that is nothing but a point. Yes. So my answer would be here a point because I can show by marking it as point A, but I cannot measure it. That is what its magnitude. Okay. So let's move to the next question. What they're asking here? How many endpoints are there in a line? First one is in a line. If I consider the line, let me know children that how many endpoints have? We don't have any endpoint. So only a line is denoted with both the sides arrow marks, means it moves endlessly in both the direction. So my answer is here none. Now same way for the second one. The second one is a ray. Now for ray, how many endpoint we have? One. That is a starting point, but no end point because until this where it reaches, we cannot measure it. It moves infinitely in one direction. So here for ray, I will write as 1. Now same way the third point is a line segment. Now you tell me children, a line segment means it has a fixed distance between the two endpoints. So how many endpoints we have? Yes, for sure we have 2 endpoints. Am I right children? Yes. Now let's begin with the next sum. That is here. The surface of a book, what they're asking here, the surface of a book is plane. Is this statement correct? Now, if I will hold this book in my hand, children, can you tell me its surface is plane or not? Yes, its surface is plane. Then they are asking why it is plane. That we have to mention. So here I will write first the question or statement asked is correct. That is yes. Why? Because there are several sets of, what they are telling here, there are several sets of 3 non-collinear points. Sorry, 3 collinear points. 3 collinear points. Okay. On it that can be determined, collinear points on it that can be determined, that can determine that plane, that can determine that plane. So here understood the reason why the surface of the book is plane. Okay. Now let's move with the next question. What they're asking, how many lines can pass through? The first one is 1 point. If I take 1 point, how many lines? N number of lines, uncountable. So that will be known as here as infinite number of lines can be passed through 1 point. Now same way they are asking 2 distinct points. If I give here any 2 distinct points, you tell me how many lines can pass through this? Only 1. Yes. So here my answer is 1. So hope that your concept regarding this is clear. Let's move with the next sum. So let's move with the next sum children. What they are asking here. If 2 lines do not intersect, are they always parallel? Yes, not necessarily, but most probably when those 2 lines do not intersect, they are parallel. But not required, they will be parallel only. We cannot predict it. So not necessarily, they may belong to 2 non-intersecting planes. They may belong to 2 non-intersecting planes. Okay. Now let's move to the next sum. That is here. So question number 9, children. Out of that fifth one, if two lines do not intersect, are they always parallel? Not required that all the two lines which do not intersect should be always parallel. Okay. So here we are giving the reason. Not necessarily they may belong to two non-intersecting planes. Okay. Now same way here. Can two lines do not intersect in more than one point? Yes, they cannot. So we have written here answer as no. Now same way here children, see what is the next question. Two planes are either parallel or they intersect each other in a point. Is this statement true? Give reasons. Now if I take two plane surfaces, it is not required. So here, no, if they are not parallel, they intersect in a line. Somewhere they may intersect. Okay. Now, same way, see your question number 8, what they have asked. That is the point of intersection of three lines called the point of concurrence or the point of incidence? Whenever the three lines meet at a point, they are known as point of concurrence. Okay, children? So let's move with the next sum now. That is question number. So here, the next question which comes is ninth one, that is, what are the maximum and minimum number of points of intersection when three lines intersect? So when three lines are going to intersect, how many maximum number of points we may get? So that is maximum 3 points and minimum 1 point. Without 1 point, you cannot intersect the lines, isn't it? So here, maximum number of points are 3 and minimum number of points are 1. Now, same way here, the last question is, if point A, B, C are collinear and B, C, D are also collinear, then are the points A, B, C, D collinear? Yes, obviously collinear means what? Lying on the same line, those points are known as collinear. Now, if I have taken this line, I have marked A, B, C, and again I mark D, or again if I increase one more, means what? It is lying on the same line. So they are known as collinear. Yes, they are collinear. Now let's move with the 10th question. That is here. Name the non-concurrent and concurrent lines in the given set of lines. Now here first I need to name which are the concurrent and which are the non-concurrent lines of the set. Before going further, so here concurrent line means if three or more than three lines pass in a plane, they are known as concurrent line. Now here first two you can see U and T. They are not intersecting and they are not more than three. Three also not there. So they are non-concurrent lines. Whereas here R, P, Q, S. Four lines are there who are passing through the one intersecting point. They are known as here concurrent lines, isn't it? So same way here now. Let's move with the 11th sum. Now here the figure is given is that here the figure is given. See here, first line is P which is passing through the, and here line O and line B are intersecting. Again line Q has passed. Again one more line L and N are passing through the D, isn't it? So here I am having an intersecting point as a C. Can you see here intersection point C? Here is also one more intersection point. Here also one more intersection point is there. Now let's check what they're asking in the question. Okay. So here they're asking, name 5 pairs of intersecting lines in the figure. Name the points of intersection of these sets of lines in each case. Now see here, R and Q. First line is here R and Q, which are intersecting at A. Second one is P and O. See here, P and O intersecting at B. Same way here, M and N intersecting at D, right? And L and N, same, intersecting at D. And N and Q. Can you see here? N and Q. Okay. So same way here. Now move to the next question. Which lines are parallel to each other? Now parallel means what? Same distance should be there, right? So here line, which line is parallel? R is parallel to N. Okay. So here what we get is, see here, can you see this line R? Sorry, this line R is parallel to line N as there is the same distance between them. Now same way, let's move to the next question. The next question is, which is the point of concurrence of the lines P, R and O? Now if I will see line P, if I see line R, and if I will see line O, see here, line P, line R and line O. B is the intersection or concurrent point. We can call it as point B. Is it clear to you? So you are going to write here as a point B. Let's move with the next question now here, children. Are lines L, M, N are concurrent? Now if you see in the figure, that is only L, M, N are concurrent, not the O. Same here, are there any two lines which have more than one intersection point? No. So name the sets of concurrent lines. Pair 1 is PRO, pair 2 is OQN, and pair 3 is LMN. We'll go through the figure, you will understand it. Okay. So let's move to the last question of this exercise. That is, write if each figure has a curvilinear or a linear body. Now curvilinear, what does the word curvilinear means? Curvilinear means which is having a curved shape. Now which are those? And linear means line, which are made up by the line. So here in example we are having the first one is circle. I have written directly the answers, you need to write the question also. So here curvilinear, that is first one, that is circle. Second one is square. Square is a linear because it is bounded by the straight line segments, isn't it? Same way now box also. Straight line, so it will come under the linear. Diamond also will come under the linear. Oval, which is in circle shape or curved shape, we can say, isn't it? So that will come under the curvilinear. Now same way here, ball is also in a circle shape, which will come under the curvilinear, and remaining rectangle and a brick will come under the linear one, isn't it? So here we have completed with the exercise 4.1 basic geometrical ideas. Next we'll move in the next session. Till then, have a nice day.